Good morning. Okay, that sounds a little bit better. Try again. Good morning. This is the machine learning conference. Let's do good morning. Your voice has to sound like data, high quality. Right? It can't sound like our model. Agreed? Let's try that. Good morning.
Good morning.
Excellent. That's a good start. All right. Where are my slides? Sorry, guys. Slides are on there. Slides coming? Perfect. All right. So, what are we going to talk about today? We're going to talk about unlocking new todays. So this is not about what you can do 5 years from today. This is about what you can do today. And this is about how you can take advantage of capabilities that are available in the market today to create new innovations. That's all I'm going to talk about. It's very, very simple, right? First question, what does AI make cheaper? I saw good morning energy. Let's see the response energy here. What does AI make cheaper? When you do AI, something becomes cheaper. What becomes cheaper? You are almost there. He said intelligence. He's almost got it right, but the answer is slightly different. It's not intelligence per se. AI doesn't make computing cheap, man. That's AWS. We make it cheap. I'm sorry? Effort, not really. Effort doesn't change. Actually, if you go to physics, effort doesn't change. Mechanical advantage doesn't change, right? What happens is your load changes, effort changes based on mechanical advantage. But there's something else that changes. Come on. I got like 30 seconds more on this. Human intelligence becomes cheaper. I am not so sure, ma'am. That's very disheartening to hear. Okay, I'm going to give the answer. It makes prediction cheaper. What happens in an office? What do you guys all do? I mean, if you're developers, you're really lucky. But if you're a manager, you are in like really sad shape. What happens is you're sitting in meetings 7 hours predicting what I have to do next. What happens in a meeting is you're sitting there discussing how do I make a decision. And the decision involves a future state. And that future state is a prediction construct. Right? Should I do A or B? It's sort of like watching that serial, right? Black Mirror, Bandersnatch. Should I go with this answer or this answer? And the story changes. It's wonderful, right? It's sort of like that. Something changes when you make those decisions. Good or wrong. I mean, the right and wrong of a decision is a very different science, right? Let's not go there. But what AI helps you do is to take these predictions and make it cheaper. Because what it would otherwise is costing you is sitting in a room with 5 people having these fantastic opinions on why you're going to make the decision. What AI did was make it cheaper. If you think about it, that's all it did, right? That means the velocity of your business starts improving. That's the reason when you talk about AI business cases, you shouldn't be going with 30% cost reduction in AI. Something is not wrong with you. It's not right with your business case. It should be orders of magnitude because all those people don't have to sit around and make those discussions, right? So that's the real business value of AI. If you go do the math, you will see the business case for AI is phenomenal. Sometimes 100x, sometimes 1000x. All right. So at Amazon, we do a lot of fun stuff, right? The most interesting thing is we recommend stuff to you. You go to the website, you take a look, we say, hey, this is a product that you can buy. That's recommendation. We've been doing this for only 20 odd years. Right? Then we do other things. We predict the right price. That should be done. And there are a lot of companies who do that. But in essence, if you look at what happens with AI, there are 3 fundamental things, and there's more you can do, but 3 fundamental patterns that I have observed, which is seamless experiences that we want to give to customers. That makes things easy, right? Makes it easier for them to do things, experience things, shop things, whatever it is, right? Whatever you're offering to your consumers, your customers, your employees, you want to make it much more seamless. You want to automate the fundamental aspect, what required previous human effort or something that we could not imagine doing in our normal scales, we can do very differently now, right? Automate that. Or fundamentally do scientific breakthroughs that we previously thought. An earlier speaker here, I think it was like a couple of sessions before this, talked about the fact that when you're building neural networks, right, there were days where we thought natural speech recognition is never going to happen. And today we are willing to take it for a fact. Actually, I don't know if my kids will assume that machines will talk, right, and talk back. I mean, we have a fantastic robot outside that's talking to you. right? So think about it, right? So you are going to have these as very natural. I mean, how many of you were in school without a remote control for your TV? How would you like to be without it today? Correct? Remember, try is giving you a choice. They're giving you a choice to drop it. You don't want to be without it today, right? I mean, that's an entire change that's happened. Imagine our kids today without an Alexa. They'll be like, what are you talking about? Everything has to talk. Correct? That's going to be the state. So those are scientific breakthroughs, whether it's in medicine, whether it's in integration, whether it's in engagement, that's going to happen. So Amazon Go Store, most of you would have seen the video, I'm not going to bore you with that. Fundamental seamless experience. Recommendations, fundamental seamless experience. You buy a policy on Policy Bazaar, fundamental seamless experience. How do they design these things? They design it because they have the ability to drive that experience by completely automating many aspects of what you do. Right? This is our warehouse. These orange things down there are actually robots that actually move shelves. The idea is Amazon can guarantee 2-day shipping, whether you order 1 million orders on one day like Prime Day or Black Friday or a Big Billion Day, etc. on one side, and on the other side, we have the ability to non-linearly scale our business. Right? You need to be able to do that. Business value behind the scenes. We didn't do this project thinking we want to do an ISO 9001 warehouse though. That's not how you think about it. You say, I want to guarantee my customer 2-day shipping. And then you work backwards from the problem, from the business problem of guaranteeing 2-day shipping and saying, what should I do to my warehouse to make that? Right? And then we figure out, okay, where can I optimize in this space? Where do I put it? We find spaces, that's beautiful red thing, computer imagery, figuring out there is gap in there, we can go put some stuff there. There is extra space utilization, can we do? I can store a packet of Lay's chips right next to Kellogg cereals because the machines are now bringing the product. Human is not going searching, where is this product? Very different science, right? This is a customer of ours, too simple. They build autonomous vehicles. They have a level 4 autonomous vehicle running in the United States market, trucks that go from one place to another. So they have been building these systems using object segmentation, convolutional networks, so on and so forth, right? And allow you to run computational. So this is an embedded video of a daytime driving and an embedded video, this ends, and then there's an embedded video of a nighttime driving. But what really happens there is the ability for you to build these kinds of sophisticated systems. When you start building these systems, it's phenomenal. How many of you have built a computer vision system? How many of you copied the algorithm from GitHub? I mean, if you have not done it, you're wasting your time. Am I right or wrong? Okay, I saw about 8 hands go up for computer vision. How many of you built a text analysis system here? Okay, a lot more hands went up, much better. How many of you copied that code from GitHub? Very good. Right? Remember, we have to reuse. Built by myself, great learning. But reuse, much better learning. Correct? So anyway, so this is Amazon Prime Air. Again, a drone that actually uses optical decision making, etc. I'm talking about these cases because I'm going to connect the dots, because what happens in the real time? When you build autonomous drones, what do you think happens? How many drones do you think we would want to eventually put out in the market? Velocity look like? Do you think your fiber cable can handle it? Have you run a scalability test? Developers understand all this, right? They understand how to do database I/O. They live this world every day. Data scientists are about getting their model right. They want to get it right. They've gotten it. But if you take it, package it, put it in production and say run, it comes up with something interesting. 8 concurrent requests, 12 concurrent requests. How do you scale it for a usage like, let's say, a delivery system that Swiggy has or Amazon has? So I have an e-commerce platform with 100 concurrent users. I need 2 CPUs. Oh, my recommendation system requires 100 CPUs. Doesn't work, right? You need to figure out what it's going to look like, where it's going to run. You want to run it on the edge. The model that you compiled on your GPU, does it make sense? So these are the underlying challenges that hit us when you find that you take AI to the real world. At Amazon, we've been focused on a fundamental problem. We see these problems every day in our business. We see these problems with our customers using this. So we started with an agenda about 2 years ago and saying that we have to democratize AI/ML. Right? In our heart, we believed, and we did that in 2006 with IT technologies, which is cloud. But we said we have to democratize. And the word democratize is very loosely used in a lot of places. But if you step back and think about what is democratization, is the ability, think about it in a very simple manner. How many of you have seen a calculator on a desk? In an office desk? It's there, right? A lot of people have a calculator on a desk. A lot of people have a pen, paper, and pen stand, etc. on a desk. How natural is that for a number of places? If you're just in the IT field or IT services field, you probably have the equivalent of a small stationary unit around the corner of your office where you can get a stapler pin, this thing. These are democratized technologies. You go access this thing, there is a photocopier, there's a bunch of technologies that you use to move your day-to-day work forward. That's democratization. It is just assumed it is going to be there. You come to a conference, you see 2 coffee machines on either end. It's democratization. Correct? It just is there. You take it for granted. You go home, you watch it, you see a television box somewhere, right next to it somewhere in that area is a remote control. That's democratization of technology. Democratization is the ability for it where it says every single individual of you should have the ability to be able to take advantage of AI. Correct? It is not about there are 10 people who are going to do it and the others are just going to watch it. No. You're all going to be able to do that. It's going to take some time, but you're all going to be able to do that. And in that process, we started out on a journey and started putting out a stack. And we are 2 years into the journey. Not very far. 2 years into the journey. The stack already looks like this. It's a pretty busy slide. Right? And we have a long way to go. I'm not going to go bore you with all of the stuff there because that will be horrible. I'll try to see if I can finish it before so that you can do some Q&A. But the AI services up top are for anybody. There's a bunch of things there. I'll talk about it in 1 minute. But it is for anybody who says, I don't want to do machine learning on my own. I'm going to consume a service that somebody offers. Correct? What can I do? I can see, hear, or talk to start with. Software normally doesn't do these 3 things. Have you found out? It can process data. Software can't see, software can't hear, software can't talk. With these services, you have vision services where you can see whether it's an image or video. We'll get into the details. You can read the documentation. It's straightforward. But there's a set of services that can help you see. You can do OCR. You can look at what's the text in there. You can detect objects in there. You can do facial comparison. You can figure out how Madhu has 2 eyes, whether this ratio of my faces to the picture is 87% or 67%, whether it's a passport size photo or not, how many faces are there, boy, girl, emotion, empathy, done. Right? That's vision services. You have speech. I have text. I could now have my number a little bit wrong. It's 50, 52, something number of languages and voices, that 23 languages, 50 odd voices that you have that you can deliver against, right, from text to speech. Very natural sounding. That's this voice that I like, right? It's called Aditi in Pali. What it does, it can actually speak Hindi and English simultaneously. The beauty is the input text you can give in 3 forms. You can give it in English, you can give it in Devanagari, and you can give it in Romanagari. What is Romanagari? Romanagari is when you type Hindi in WhatsApp. Have you seen it? You'll type all Latin characters, but the word is Hindi. Right? Mera naam would be MERANAAM. Aditi figures that out, that you're actually saying Hindi words but typing it in English. It'll actually pronounce it in Hindi. That's Romanagari. Right? So we can do that. We can do transcribe, of course, right now in English to go from voice to text. Language understanding like translate, which is language about 60 odd language pairs, comprehension, give a body of text, I'll break it down to JSON, give it to you as data, key phrases, entities, etc., etc. Chatbots, you can build chatbots and have fun with it, etc., etc. But there are 2 things in the end, forecasting and recommendation. That's based on Amazon technology. What we did is, a lot of people said we want to build recommendation systems. I said, great. You know what? We build recommendation systems at Amazon. Simple problem. So what we did is we said, don't worry about it. We are going to give you the entire pipeline of how we build recommendation systems. You don't need to have any knowledge of AI or ML. You take your data, put it on one end, we will generate a custom API for you on the other end. That will be your recommendation API for your data. Simple? We will run the pipeline. You constantly, and when you have click streams and other things coming and buying products, feed that back into the loop. It's a continuous ingestion pipe on that side, continuously improved API for you. You don't need to have any knowledge on AI. We will do that for you. That's our recommendation system. Then we did the same thing for forecasting. Why did we do forecasting? Because that's something that we do well. Think about it. How do we know that you're going to place orders on the following items on Prime Day? Because we still have to ship it to you in 2 days. If the item is in somebody else's factory, it won't come to you in 2 days. It has to be in our warehouse for it to reach you in 2 days. And we'll have 10 times the order or 5 times the order on that single day. So we have to stock those products upfront by forecasting what the customers would order and how much they would order. Right? We do that for our manpower. How do we get all these additional manpower on that day? So those are forecasting algorithms. We've been doing it for 20 years. So we packaged it and said, give us your data, your setup. We are not going to copy the data. Goes through the same construct and we'll generate a custom API for you. No machine learning language knowledge required. Those two we solved and we said, here it is for you. Take it, use it, go ahead. But then there's a machine learning conference, right? And we look at what are the steps that we need to do that we can do below. What happens when you want to work with your data, build your custom model? And we started working out with a lot of customers on figuring out what's going on. And it's not a small set of customers. Those are the customers we are working with. Right? Many of these brands you can recognize. The slides are deliberately small. But you can see Tinder out there, Snap out there, etc. Right? We actually sometimes say that pretty much any relationship that happens in the world happens to be via on AWS platform right now. Because whether it's Shadi.com, Tinder, Snap, etc., runs on us. But think about it that way, right? So you have a whole plethora of customers using AI and ML services on our platform that's giving us feedback and input that's telling us very clearly, these are the problems we face when we build our models. And Amazon is very simple, right? We are customer obsessed. We listen to customers, we hear from customers and say, we will do the undifferentiated heavy lifting for you. And in doing that, we say, we're going to innovate very, very rapidly and give you the services. And this is what we heard. ML is a lot of work. It's not easy. It's not like software engineering. We can't get started 6 weeks later, 8 weeks later, something would work. No, it's not happening. It is science. It's hard. So what can you help us with? So we launched SageMaker 2 years ago, which is a managed machine learning environment. It can go everything from choosing your algorithm to all the first 5 steps, right? Except the collect and preparing training data. That's the hard one. You could build hosted Jupyter notebooks, and there's an advantage in building on the cloud versus building on your laptop. Anybody who know what the fundamental advantage is? Why you should not build machine learning on your laptops? Huh? Why you should? How many of you build it on your laptops? How many of you run your training on your laptops or anything like that? No elasticity, but what's the real problem? Elasticity is not an issue on your, but many people try, right? You have a dedicated machine for every data scientist. Volume of data is one thing, but there's a much more important situation. Data is correct, but it's not just volume of data. Processing power is easy. I can give you a dedicated GPU-based machines. What, scaling what?
Scaling in terms of how much I really need. I would not really computational resources.
I'm talking about training. Do you know something? Your data scientist actually has access to your data. How do you manage information security? Has your CISO reviewed that process? Have you tried it? How are you compliant with GDPR? On-premise has nothing to do with it. Is that employee who is looking at that data, processing it, how sure are you on that data set? On what it is doing and where it is moving? If it is it? Questions? You don't have to answer that. That will be self-implication. Think through this. Information security is your number one challenge. You not only have to anonymize the data, but remember, anonymization also causes its own challenges in machine learning bias, right? But there is another challenge that you deal with. You have to now figure out, how am I going to keep all this data? And remember, the data set keeps on growing. You're bringing more and more data. There's a lot of data out there. You have to keep it, storage it, and when people try to bring it to their local access node to run training, you have an issue where the data scientist has direct access to the data. They can copy it. It can move. It can go to USB sticks. It can go to removable hard drives. That's your starting point. Information security should be priority 0. Number 1, right up there. Then we'll worry about compute, GPU, CPU, etc., 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 etc. But if you don't factor that right, the rest is going to be a challenge. Because you will build everything, your process looks right, and then you have an information security. Hey, have you taken care of it? And then your process goes all over to square 0, and then you start all over again. As long as you're doing a theoretical experiment to see how do I know how to do something, fantastic. But if you want to do something for the real world, with a real problem, you need to figure out how you're going to solve that. Anyway, so that's the reason you probably want to be on a fully managed environment so that you have the ability to control the landscape of data and how it's being accessed. You need to know how many times it's being accessed. Data leakage prevention is something that you have to handle and how to handle that, right? So you choose your algorithm and SageMaker can do all of that for you. But then we said there's a lot of cost, there's a lot of issues with data, there's an issue with ease of use. It's not easy to do that. So very quickly, I'm going to go over what are the things that's happening. Improving training and inference cost. How do we improve that? At the heart of it, we launched new sets of machines. These are fairly fast machines. Just to understand this P3DN instance, giving you some examples here, not all the different, I'm not going to walk through every single instance. This is now a 100 Gbps networking instance. It has 96 Intel Skylake CPUs, Intel cores that runs with it. It is 32 GB per GPU, which means it has 256 GB of RAM, connected to 8 Tesla V100 GPUs. How much processing power is that? A little over 1 petaflop on a single machine. Do you know how much this machine costs? $24 an hour. How many of you used a supercomputer before? No? You have. Great. What is a 1 petaflop machine? 1 petaflop machine, supercomputer. Where will it stand in the top 100 supercomputers in the world at 1 petaflop? It will stand in the top 25 somewhere, right? Just by this one instance. By the way, you can cluster it. That means you can actually have an 8 petaflop system or 16 petaflop system at $300 an hour. Let's see what it can do later on. So, scaling TensorFlow. Everybody loves TensorFlow. We love TensorFlow at AWS. It's brilliant. We can do other things as well. So, we love TensorFlow, and we found that TensorFlow, when scaled, right, utilizes about 65% of your GPU. It doesn't push hard enough. So, for example, if you're using 256 GPUs and you're trying, each machine node has 8, you take 8 P3DNs, put them on a 100 Gbps fiber and say, 65% utilization of the GPU. Expensive stuff, right? But that's all it can do. So we said, let's optimize it. We optimized TensorFlow on that platform to take it to 90%. That means your cost will say, okay, let's translate this to real world numbers. In Mountain View, you know where that is, it takes about 30 minutes to run ResNet 50 on that kind of environment. Custom, specialized hardware, it will take 30 minutes. We can do that in 14 minutes. You can do it in 14 minutes. So how long does it take to do ResNet 50 now? If it's only 14 minutes, build by the second. Assuming it takes 15 minutes for you. Do the math. $100? Cost comes down. But it's not just ResNet 50. I can do this for any CNN, any RNN that I want today. That's the level of optimization, because TensorFlow has been optimized by us so that it runs on the platform much more efficiently, pushing your GPU to its limits, right? And getting the necessary outcome that you want. Training gets a lot of attention, right? But the real world problem, is that if you look at it at a compute and cost standpoint, it is your inference that's actually more expensive. It's not training. Training, yes, is a hard problem. We solve it. We work through that. But the thing is, when you hit a particular scaling point, it's inference that's actually much more expensive. You will have to do inference much more effectively. You have to figure out. So at runtime, we get into a lot of challenges. So we built this capability called Elastic Inference Engine. What it does is it allows you can choose whether you want 1 teraflops or 32 teraflops, and you can go ahead and connect it to any AWS instance and say, hey, regular compute machine, I want a little bit of inference here. Right? Let's say you're doing machine vision, computer vision. You're running a simple thing. You need only 1 or 2 teraflops, right? Whereas if you're doing fraud detection, you need a lot more because the models are much more complicated. Your models are bigger. So depending on that, you can choose which you want. And remember, it is MXNet, TensorFlow, PyTorch right now, ready to go. So ResNet 50, let's say you build it, 360,000 image inference in 1 hour, 22 cents. Does it bring your cost now lower? That's real cost, right? That's real cost that you're able to bring lower. Because I can now do in 360,000 images, that means approximately 10 images a second. Look at the concurrency value now. I can do 10 images a second on a machine at 22 cents an hour. Correct? That's the concurrency. That brings your cost down substantially. That's elastic inference support. But scaling machine learning within your team, therefore, has to be something that you have to do. We are working with all of these customers, everything from pre-built notebooks all the way to auto scaling. Because once you've built the model, you have to scale the model, supporting the necessary inferences to support that, right? I mean, you have customers like GE Healthcare, Snap, Liberty Mutual, Dow Jones, etc., working with us in supporting that. The real problem, data. How do you solve that problem? Everybody knows these. There's data set outside, you can take a look at it, right? And that's what you want. How many images will you do it for India? Let's say I want to detect all the items in the kitchen. How long would it take? Kitchen is a nice place to do experiments. All the different Indian vessels are amazing. They all look shiny silver at different sizes. Do you know which one to pick to give instructions? If I'm cooking, you have to give me explicit instructions. It's like, Madhu, pick up the 3/4 cup that is in the 3rd shelf top right. If you said, pick up the 3/4 shelf, I'm lost. Correct? You have to be explicit about it. Same thing with, if you're going to build an ADAS system, if you want to build a recommendation, if you want to build a Go store, you have to know what I picked. Correct? You have to have labeled data. You have to know I picked up tur dal and not the other one. The Go store doesn't have that problem today. Correct? But you will have to do these things. Labeling is hard. And if you've actually done real labeling, it's good. That's the reason we launched Ground Truth. Ground Truth is a labeling service. It helps your organization do labeling. What do? Raw data goes in, humans start annotating it. It's a fully managed service. Humans start annotating it. Based on that, there's an active learning model that picks it up and starts applying the active learning into the existing label data that the humans are doing. And it starts figuring out, can it automatically label it by itself? And it progressively learns. Whatever automatic annotations are there, that becomes a training data. But then, wherever the active learning model comes up with a very, very low probability, very low efficiency, it then sends it back to human annotations and say, hey, improve that on me, and then I'll learn again. Let's say you have 100,000 pictures. How long would it take? What happens if it is 1,000,000 pictures? Let's say, for example, you want to recognize all the characters in Hindi for OCR. You want to do it for Gujarati. You want to do it for Bhojpuri. You want to do it for Tamil. You want to do it for Kannada. What happens? The different ways of writing the same thing. You have to do this, right? That's how you build data. So, where are the people? Madhu used nice slide, but where are the human annotators? I have only 4 people in my team in my startup. Correct? Natural problem. So, you can use Amazon Mechanical Turk workers, private labeling workforce, or third-party vendors. We have partnered with a set of third-party vendors who can do it. When you set up the workflow, you can say, I want to use these third-party vendors. Contracts established, execute, ready to go. Or you can use a global general workforce, completely blind, assuming your data can support it, Mechanical Turk workers. Or you may want to just shovel it to your employees and say, guys, every day 1 hour lunchtime. Works very well, right? That's there. So you have the ability to do this really, really quick. Driving ease of use. You have this marketplace. There's a lot of how many come from an enterprise background? Few hands go up. Okay, enterprises they want results quickly. So for them, we have launched AWS Marketplace. What happens with Marketplace is you have pre-built models from companies that have built it that are available on the marketplace that you can simply consume brings your cost down. Don't worry about training. Don't worry about building. Ready models. So I want an NLP model for something. If there's a company that's out there, publish it. Or if you're a developer, you can build a model and put it in the marketplace and start making money. Right? There are two ways to think about it. That's what the marketplace is all about. Build models, put it out to their market so that somebody else can consume, just as a model. Or for companies that want acceleration, buy the model, start consuming the model in your own SageMaker environment, and you scale. Over 150 models and algorithms available right at this point across text, OCR, speech identification, regression, object identification, etc., text clustering. I mean, name it. It's growing very, 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 very fast for you to scale up. Next problem. I built all these great training data set, but I want to run it on a camera so that I can detect facial people. I want to run it on an edge device. I want to run it on a drone. I want to run it somewhere else. You come up with a very interesting problem. You've built this on these frameworks, but your targets are like that. You build on Intel, NVIDIA, but you may have to run it on a Qualcomm something else. Correct? Your model file is not optimized for the target CPU, GPU architecture. Right? It's not going to do very well. It's not going to scale very well. SageMaker Neo. Cross-compiler that will compile your model from one infrastructure to another. You build it on Intel NVIDIA, you can deploy it on a Qualcomm. By the way, SageMaker Neo is open source. If you have a target platform of your own, if you want to add it, you can go ahead and do it. And you can extend it. Existing partners to do that. So compiler runtime are open source, 1/10 the size of the original models. That means you can compress them. You don't have to keep them loose. You can compact them, you can deploy them. Alexa, local inference, same thing, right? We build the model in one area, we optimize it, bring it down, deploy it on a small piece of hardware. Then reinforcement learning. We did supervised learning, unsupervised learning. What is unsupervised learning? You all know that. I mean, you're all machine learning guys. I'm not going to tell you what it is. Unsupervised learning, supervised learning. That's an area we don't want to touch. Reinforcement learning. Right? Sophistication of ML models with lower quality data. So build a scoring function, build a reward function, oral algorithm, go. This is something new that we did this year. So we wanted people to learn. Last time when we did SageMaker and IoT, we gave you deep lens for you to learn. And this year we said, we will enable you to learn on a fully managed, ready to go environment. Full simulation environments available for you to do RL, Intel OpenGym compatible. It is also, you can use Amazon RoboMaker as a simulation environment. You can also use Sumerian as a simulation environment, and you can build it. Today morning, there is a nice blog that talks to you about how to use Sumerian as a simulation environment for your reinforcement learning. That is there. And then we wanted to get developers ready to go. So we launched AWS Deep Racer. This is a toy car. It's an autonomous car that you will build on your own. Right? Comes with a HD video camera, gyroscope, 4-wheel drive, dual power compute and drive, accelerometer, dual core Intel CPU. It's a toy that you can order right off Amazon.com, not in .com. And then what you can do is you can figure out, you can train this on the RoboMaker platform and set up a track at an event, in your office, in your store, and you can have the autonomous car learn over time. This is how you learn, teach your developers reinforcement learning. And it's a nice, cute project as well, right? Not very expensive. That was not enough. So we said, why only make the car? Why can't we make it a racing league? So we launched Deep Racer League. What is Deep Racer League? If you have Deep Racer, there are two ways in which you can compete. You can compete in a virtual event without the car, or you can compete in a real world event with the car, right? And that is now available. The winners would be given tickets to reInvent, to come there and showcase their work. Learning and developing your skills. We know there's a lot to learn. Machine learning is still day one. Our Machine Learning University for you to pick up your skills and see what you want to learn. Fully free, fully accessible, right off our website. Right? All of this is available. All the infrastructure is available. Ask your account managers, talk to our teams. There's a booth outside. Talk to us and figure out how do you want to work on this. There's a lot of opportunity out there. We're very happy to help you in that space. Thank you.